I'll quickly jump into the second panel. We have experts both from the government and the industry. And before I introduce our expert panel, as the moderator, I've taken the liberty to prepare a 5-minute presentation on what we found in terms of the existing barriers and required interventions for natural refrigerant and NIK technologies. To give you a quick overview as I pull up my presentation, we had surveyed about 7 MSMEs with working across different sectors on natural refrigerant and NIK technologies, and as well as they had work in HFCs and HCFC based technologies, and 14 technical experts and policy experts in August and September 2020. Following this, we did a more in-depth semi-structured interviews with 7 sector experts in April 2021. Through these questionnaires and conversations, we tried to understand, are natural refrigerants ready, or NIK technologies ready to be to replace existing conventional technologies? What are the existing barriers, and what are some interventions that could help overcome these barriers? When we asked about the replaceability, which is the most important question to address at this point, of HFC-based technologies with natural refrigerants, the answer was an overwhelming yes. Across sectors, a majority of our respondents said that natural refrigerants were suitable alternatives. When asked the same question for specific conventional technologies used specifically for space cooling, VRF, chillers, room air conditioners, again, the answer was overwhelmingly yes. Various analysis in the past estimated the place of natural refrigerants in India's RAC or RAC market at the fringes. A 2017 analysis by Terry predicted that while HFCs increase due to the HCFC phase out in 2030, the predicted place of natural refrigerants is at less than 1% of the total refrigerant demand in 2030 under a business as usual scenario. However, I think in the previous presentation, Mr. Bhushan mentioned that about 3/4 of the RAC sector can currently be converted into natural refrigerant-based systems with existing technology. So why hasn't this happened yet? And the answer is that there are barriers, and this is not straightforward. So if we look at concerns around safety issues for natural refrigerants, toxicity, flammability, these have been addressed in India by BIS's adoption of safety standards for both ammonia and hydrocarbon as recently as 2020. But the gap remains that how do we implement this and make sure there is the opportunity to build confidence both among the industry and consumer base. So then do we address the high cost? So if I say simply bringing down the cost is the solution, I think the gap then remains that there is a lack of capacity in the sector, as well as a lack of awareness among end users, and that's why the problem continues. And of course, synthetic refrigerants have the upper hand because they can be designed to be retrofits. And not addressing any of these already aforementioned barriers ultimately leads to a status quo, a skeletal manufacturing setup for natural refrigerants, and of course, the NIK technologies. During a conversation with manufacturers of these alternative technologies, the issue was not as much the skeletal manufacturing setup or even the high cost. I think it always went back to we don't have the capacity or we don't have enough number of users of these technologies. So I think the fact remains that technology readiness exists, but efforts need to be made or they need to be directed at creating a conducive environment for their manufacture and easy deployment. supportive policies can play a very important role in promoting these technologies. This could be in the form of maybe quotas in our upcoming refrigerant phase down for natural refrigerants, for HFCs. We also need targeted capacity building. And I think Mr. Rapole had mentioned this previously, where you promote or where you raise awareness and equip stakeholders ranging from engineers and architects that are currently practicing, students, technicians, plant operators, factory inspectors, policymakers, senior executives of companies, and consumers as well. And the most important link or the most important aspect here is also the provision of economic incentives. And this is something that we kept going back to when we were talking to both sector experts and industry experts, where there is a need to make technologies cost competitive, which will again help build or bolster the skeletal manufacturing setup and create a conducive ecosystem for the uptake of these technologies in India. Now, I'll quickly revisit the TERI analysis I previously mentioned. They further showed that under an ambitious scenario of realizing ICAP's target of reducing refrigerant demand by about 25% by 2030, HFCs continue to be a dominant refrigerant. And this is where the ICAP becomes important. At this point, ICAP remains agnostic about natural refrigerants, and that's a direction that is acceptable. However, there needs to be a mention of natural refrigerants as an essential need for India's refrigerant transition. In the absence of this, there is no plan for R&D or demonstration projects or any motivation to push for these technologies. There is also no awareness on natural refrigerant or NIK technologies. Access to thermal comfort through passive cooling or alternative technologies, when mentioned in the ICAP, is limited to affordable housing projects. There is certainly a scope to go beyond housing to public buildings and infrastructure projects to demonstrate these technologies. And finally, the ICAP needs to address retrofitting of green cooling technologies, as again, this is going to be a challenge when we are talking about rehauling an ecosystem. With that, I will bring my presentation to a close, and I will take this opportunity to introduce our panelists. We have Mr. Krishna Nagahari, who is the Director of Industry Affairs and Regional Hotspots at Danfoss. Mr. Nagahari is one of the key leaders with Danfoss India to support the company's continued growth in the country with his specific area of expertise in sustainable development goals through energy efficiency. Welcome, Mr. Nagahari. I also have Dr. Prasanna Radauntala, who is the Chief Technology Officer at ATE Group. He's passionate to develop product solutions and teams that solve environmental issues, and has catalyzed over 21 new products and process innovations in diverse sectors, including energy efficiency and renewable energy, membrane separation, and water treatment. Welcome. We also have Mr. Tanmay Tathagat, who is the Executive Director of Environmental Design Solutions. He's an expert in building energy simulation and has worked on a range of government projects for developing sustainable policies for the built environment. And we have Mr. Rajneesh Khosla, the head of Mechanical Engineering Department at Bureau of Indian Standards. Mr. Khosla oversees the work of 28 sectional committees of Mechanical Engineering Department involved in standardization activity for various mechanical engineering products. He is also member secretary of MEDC and Energy Management and Energy Savings Sectional Committee, MED 39. I welcome you, sir. So, having presented our findings on the barriers that current alternative technologies are facing, I would like to open up this panel discussion with a brief overview by each of our panelists on what their impressions are based on their experience with the sector, on the current barriers and the way forward to mainstream these technologies. Would anyone like to volunteer to go first?
May I start? I
Yes.
have a very small presentation, so I'll just share that.
Sure. You should be able to share it right now.
Okay. Uh, I would start with just a small introduction of BIS, that BIS is the national standard body of India, and we are representing India in ISO and IEC. We have formulated more than 20,000 standards, and we are actively engaged in these areas of refrigeration and air conditioning, and also natural refrigerant. We have our headquarters in New Delhi, and we have 33 branches. So coming to the specifics, we have a particular sectional committee dealing with refrigeration and air conditioning. And we have published 48 standard. In the last 4 years, we have been actively working with Ministry of Environment and Forest and iForest and uh, uh, other agencies, trying to bring in more standards, more visibility to the natural refrigerant. Uh, we have formulated the following standards. We have adopted a few from ISO and IEC. These are the basic standards that we have introduced. The latest being the IEC 60335 Part 240 standard, which gives the particular requirement of electric heat pumps, air conditioners, and dehumidifiers, and using refrigerant of A1, A2L, A2, A3, and A2L refrigerant. So with this, we have now basically given the base to the industry, to the government, for the introduction of natural refrigerant in a large scale in the market. I think, like it was just pointed out by Arupa, that though we have these technologies for quite some time, I think many companies in India are already working on these technologies. However, the level of the level of confidence in the customer and the government was not there. Now, by introduction of this standard, we now think that now the Indian industry and the government can use it to use it, and the natural refrigerant can come in the Indian market in a big way. These standards are also referred in the main standards. So once standards like freezer, air conditioner will comes under the quality control order, these standards would also become mandatory. So to follow these standards, so there will be no air conditioning company who would be making the products using natural refrigerant but not following this standard. However, to as a overcautious view, BIS has been collaborating with Ministry of Environment and Forest, and the Ministry of Environment and Forest has been kind enough to finance a study on the safety aspect of natural refrigerant in IIT Delhi, and that study has finally got through, and I think by December we will be getting some inputs in how we can increase, taking the Indian conditions into consideration. We can then add those added safety requirement in this international standard, so that the confidence of the government as well as the industry while using natural refrigerant, like it was pointed out, they have high flammability, they have they have toxicity matters. So I think the confidence level will increase. We have also taken designed a code of practice for design and installation based on the Association of Ammonia Refrigeration, who have been very kind enough and collaborated with BIS in making of this huge practice. Now, I think with the use of ammonia, there was a lot of safety aspects that were attached. I think with the culmination of this standard, I think the safe use of ammonia in the case of refrigeration will also be ensured. We and BIS will be looking forward for cooperation from other industries, from iForest, that not in kind technologies like the thermoelectric refrigeration, thermotunneling, magnetic refrigeration, Stirling cycle, and all other new innovations which are kind of a replacement for vapor compression refrigeration technologies. We want your cooperation, that please let the if you know the experts, please propose a standard, let us discuss amongst the expert, and we come up with a standard with these alternate technologies as well, to build confidence in the consumer as well as the government, so that the work can move forward. Thank you so much.
Thank you, sir, for such a positive end to your presentation or your opening remarks. I now invite Dr. Dontula to present his opening remarks.
Can everyone hear me and see me? See my presentation? Good.
I don't see your presentation yet, but
oh, my mistake, my mistake. Share screen. Now? Hello?
Yeah, I can see it.
Yes.
And hear you.
Yeah, wonderful. I prepared a few slides as advised by Aprupa, but before that I should thank the organizers and the distinguished panelists for this opportunity to share our thoughts on this important opportunity as well as need. Yeah, and also thank you to iForest and Shakti Sustainable Foundation for taking up the cause in such a invigorated manner. So quickly, there is a paradigm shift needed in understanding buildings. So far, we've all Mr. Madhusudan also has mentioned this, and thank you to him for bringing this up in the last panel when answering Ms. Vinuta Gopal's question. You know, it is well established for now 25 years about that IAQ increases productivity. And since the landmark paper in 1978 on measles transmission indoors, it is well known that it increases health. The benefits are very clear, and several new researchers have been working on it. For example, at Harvard University, following all the old work done at Lawrence Berkeley. And recently in May, 39 researchers from 14 countries wrote this note in the Science magazine, that we have to start not only thinking of thermal comfort and 80% acceptability, but we have to start thinking about combating infection and improving health. And they talk, in the title itself, they talk that building ventilation systems must get better. This is, and as Mr. Madhusudan said, this has really garnered a lot of attention, but only in the technical field about HVAC systems, because more than 90% of the cases in many studies, it has been shown, of COVID cases have been contracted indoors. Now, so there was a lot of advice from professional bodies, ASHRAE, REVA, ISHRAE, everyone, and studies done, correlations made, that more ventilation is always better. But we all know that adding ventilation adds cost in conventional AC, and that has always been the problem. If you look at the evolution of standards in ASHRAE itself, every time there is a pandemic or an epidemic, the standards go up, then they come down again. So we have to think what our buildings are for. Finally, are we just transferring the cost of energy from here to the healthcare cost to the nation? Okay. And finally, this can also give benefits to the end users. Everyone talks about not in kind, but I thought I'll just summarize here quickly what not in kind I am talking about. Very general, anything that breaks with conventional technologies that are fully reliant on gaseous refrigerants, and something that can be integrated with these conventional technologies maybe also. That is how I want to make it very broad. These are the several technologies that have been mentioned. The top few are all well known, historical. District cooling with seawater is something that is, people can talk about, but there's a lot of infrastructure needed in a country like India. Like Mr. Madhusudan said, can we aggregate the demand for 1 million square feet or more, and then install chilled water piping? Absorption cooling is a favorite in industry wherever there is waste heat or concentrated solar thermal. Adsorption is also there. And the new technologies, thermal storage, magnetocaloric, and others that Mr. Khosla just before me mentioned. I'll just quickly take 2 slides or 3 slides on evaporative cooling, especially indirect, because that's what we are doing. And to bring out certain points, about this. Quick thing about ATE, we are a diversified technology group with a focus on the environment. I am here because of our sustainable cooling business called HMX. Though we like to say we are big in IEC-based systems with 150,000 TR, please recognize that this is just less than 1% of the TR requirement in the commercial sector in India today. So we are very, very tiny, yeah, but we are large in the sector. The technology is proven and it is getting more proven also. Why is this? Okay, yeah. So indirect evaporative cooling, just quickly, does very well under like evaporative cooling under dry conditions. Under hot and humid conditions, there is a problem. And this is where it does not provide a year-round cooling, And but on the other hand, there are solutions which provide both year-round cooling as well as IAQ, which can save energy, and it can be integrated with green refrigerants and all the necessary features that are coming into AC's systems as a consequence of this pandemic, and smart controls. Quickly show examples in buildings that have been done, quantified, right from well-certified offices where we give pre-cooled air to hybrid systems for residential training institutes, shopping malls, again, pre-cooled air. So when you can see, I mean, these can be used for some systems as partial replacement, entire replacements, that is what has to be done. So to summarize, I would like to share that, I would like to emphasize that though ICAP talks about energy and environment, the purpose of the building must be kept first, and that is to, occupant health and low climate footprint. So that is something that is lacking in ICAP, but that doesn't mean we should not emphasize that, especially with, the pandemic and other forecasts in the health sector. NIK technologies here, I've talked about IEC, but they're proven to maintain IAQ and save energy. And but what, like others have already repeated before me, have said before me, I would like to say that we need an ecosystem at all levels to grow and sustain such solutions. So the mandate, first of all, we have an IAQ standard which was recently published, last year by ISHRE, 10,001. Can we mandate IAQ by policy and standards first? I know this is beyond ICAP discussion, but you can't have buildings without IAQ. Then, as Aprupa just mentioned, you have to create awareness. I mean, the technologies of cooling come after the building is made. And all too often, it is the engineers who are told to make the building sustainable and green. So we have to start from architects, consultants, and why not auditors, But on that side, a lot of software tools for sizing, case studies, and other things have to be made, so that they can support. I mean, if you look at the air conditioning field, it has been highly organized for the last 50, 60 years. A lot of support information is available from professional bodies. There is a question of scale in NIK technologies and the manufacturers. But if you can partner with existing OEMs, and other manufacturers, there's an opportunity. But there's a lot about education there to be done, again, before that. And I'm pleased to see ISHRE and BIS working to develop standards on these technologies. And so the next step will be to drive their adoption, So I'd like to leave it at this point. And thank you for the opportunity, Aprupa.
Thank you. I think I'd like to invite Mr. Nagahari to sort of mirror what Mr. Dontula said, but from a natural refrigerant perspective.
Thanks, Aprupa, to sharing my screen.
Yeah, you should be able to.
Let me know when you can see my screen.
Yeah, I see it.
Okay. Thank you. And I'm audible, I guess.
Yes.
Yeah, thank you, Aprupa, Chandrabhushan, iForest, for having me here, and for the brief introduction that was given by my fellow panelists earlier. Over the next 5 minutes, I'll just basically give a overview on where do we see in terms of moving forward towards a climate-friendly cooling industry, which definitely means low GWP, natural refrigerants, energy efficiency, all of that. And these two graphs, we have spoken a lot about ICAP. So these are just two things that we try to kind of calculate from the numbers that are there in ICAP, which talks about reducing energy demand by about close to 29% by 37-38, which doesn't include industrial refrigeration. And also talks about reducing refrigerant demand by about 25%. And what I have also seen in the last 1.5 hours discussion is, which usually also gets to play around in a lot of cooling discussions, is it is always the focus on the big brother of air conditioning, and somewhere refrigeration always gets left out. What we need to also understand is it is equally an important industry, and that is going to be an industry which will grow as we move forward. And that has a lot more impact on rural India, the refrigeration piece, because that has an impact on everything that you eat. Be it milk, fish, fruits, vegetables, all of this is going to move through refrigeration. And it's important that we look at that aspect as well. And I'm happy to see that ICAP does cover the refrigeration piece as well. But a lot of stakeholders invariably in the discussions, the focus is mostly on air conditioning, which is also important. I'm not denying that, but we should give the other brother equal importance as well. Now, we have talked about natural refrigerants, and what we are seeing is that we are coming back to natural refrigerants after 200 years from where we started. And this is the fourth transformation that is already ongoing, despite the fact that we are coming into play as an Article 5 country only after 2028 and so like that. But we are already seeing that in places in India, there are people who are already taking steps in terms of moving in that direction where they are able to do it. But if we have to move towards this, we have to understand why did we move away from naturals in the first place? And some of the parameters that were already told were the reason, the safety, the toxicity, and aspects like that. So it's important that we take care of that. So safety becomes the qualifying factor for natural and low GWP refrigerants to be adopted as we move forward. And energy efficiency always has been a parameter, and today we are happy to note that even in government discussions, energy efficiency is being recognized as the first fuel in the fight with climate change. So that's a very good aspect. But in terms of moving towards natural refrigerants, along with safety, a certainty from a regulatory perspective will become very important because, like a lot of people have already told during the panel discussions, technologies are available in some of the applications. So how do we drive those applications so that technology can further develop for other applications and those can be adopted? So when I look at those challenges and what could be the driving forces, so it basically falls down into a triangle: safety, environment friendly, and total cost of ownership. Why safety becomes an important parameter is because toxicity, flammability, mildly flammability, all of these are parameters where people working in this environment should feel safe. And that is not going to happen unless, because technologies can get ready, because technological development can happen by companies. But unless there is an ecosystem that is developed which can apply these technologies, I mean, it's just not sufficient that you have a technology which can use CO2 as a refrigerant. You need a welder who can weld a pipe with CO2 as a refrigerant in it, and the industry should be willing to bring them on board, do the capacity building that is required. Even today, as we speak, there are some 1 or 2 projects that are being looked at from a natural refrigerant perspective. But what we do see there is the people who are going to come and work on those projects are not from here. How do you develop that ecosystem here? Because if we want to scale this up, that is going to be important. So when I look at these, I have basically put the way forward under 5 pillars if we have to move forward on adopting a climate-friendly cooling industry. So these are the 5 pillars that what you see on the screen. And sustainability is going to be the main pillar moving forward. And people who do not work towards that will face huge challenges. So we are seeing increasingly everybody moving towards that. But it's important that we don't look cooling sector in its silo. We need to look at beyond cooling. We need to look at how do we integrate sectors like renewable energy? How do you integrate electrification into cooling sector? How do you do sector integration here so that the energy that we are talking of is not just sustainable from a cooling point of view, but you need to look beyond sectors and look at the total system solution and bring that kind of a sector integration into the play. This will need a lot of business model innovation here, because as of today, the ROIs may not work. And unless we don't look at how do we finance this, how do we develop business models to do this, the future forward will again be sustainability in silos and again reworking some of the things to see how do we integrate these things. For that, some aspects that were brought in of how do we develop consultants, how do we develop contractors, how do you have new system integrators coming into the system who can look beyond what they are looking at, develop these capacities towards this, and collaboratively work here. And it is just not sufficient that industry works together. It is just not sufficient that industry and OEMs and consultants work here. We need to have collaboration with research institutes. That's when you can develop technology. You also have students who can come in to the sector 5 years, 10 years down the line, who know how to take this forward. And we need think tanks. And this is a very good development that we are having this talk today here. Policy directives, Rajneesh already spoke on the kind of excellent work that BIS has been doing over the last many years in bringing in standards. What we now need is dissemination of these standards to people who are going to apply these so that they know that these standards are available. And if they ask that whether your products, whether your systems meet these standards and only then I go ahead, how do you cascade this becomes important. So according to me, from a way forward perspective, I believe we work on these 5 pillars, and I think we will be moving in the right direction. And in about 10 years, we will have a cooling industry which is sustainable and be able probably to show other developing nations on how you can grow sustainably. With that, I would like to stop.
Thank you, Mr. Nagari. And now I invite Mr. Tathagat to please give his opening remarks.
Thank you, Aprupa. Let me just share my screen. All right, let me make sure we stick to our 7 minutes. So thank you. I think a lot of the discussion is already pointing towards this broader issue of looking at strategies for refrigerants of different kinds, whether they are natural refrigerants or alternatives or not in kind, as a part of a larger scheme of things. And it's tough to look at them in isolation. A lot of discussion has happened in the previous session on this as well. Over the last few years, as you know, we as EDS work on a bunch of actual projects, designing, implementing, and many of them are some path-breaking green buildings that are looking at the entire range of issues of environmental and other sustainability concerns, and have pioneered some, say, pilots and projects here and there. At the same time, over the last 10 years, we've been fortunate to look at this from a different perspective as well. So we work with UNEP to look at what could be the SCFC phase out for from the building sector as a whole. Work very closely with EESL in looking at integrating climate policy at the back of energy efficiency scale-up initiatives, and also came out with this publication on SCFC phase out in buildings. Done market research on looking at the cooling markets and where both HVAC market actually overall. And then this very interesting research, which was for Asia Pacific and focusing on a few countries to see how do you combine the ozone and climate friendly transitions. And apart from, of course, codes and standards. And all of these, I'm summarizing in a few slides sort of which relate to this. One is transition to green cooling has to, and I'm focusing right now on buildings and refrigeration here, have to look at reducing refrigerant need as the first thing. So the quantity of any refrigerant required has to be first reduced through efficiency of various kind, buildings, appliances, equipment, operational measures, all those things. So first thing is that, the greenest cooling or the greenest refrigerant is the one that you don't use. The next is, of course, looking at alternatives and refrigerant and new technologies that are available. And of course, there are finally alternative technologies. When we look at this from a perspective of buildings and refrigeration, these technologies may mean completely non-mechanical ways of meeting comfort requirements. So therefore, we come back to this thing that, panelists have raised this issue that an indoor air quality standard, comfort standards becomes a reference point for all of us to propagate these. And in the absence of those so far, it's kind of a voluntary effort for those who want to do it. So energy efficiency reduces cooling load, reduces the size of air conditioning, and therefore is directly reduces the demand for refrigerants. We have alternative technologies available, and there is no choice now. We must leapfrog from the current use to the climate-friendly alternative. So the question in the discussion today is what is it that we can do from a policy and from the market perspective of doing so. Now, I see from a policy perspective, India has the enabling environment. I know, on the one hand, we'd like to say that a lot needs to be done, but for air conditioning, we've had standards and labeling program. We've had BIS has had some very progressive standards on this. ICAP has identified it. ICAP has advocated eco-labeling. Eco-labeling criteria are part of the draft BIS standard, and we have leadership from BIS who's actually taking this forward on the ground, and market-based measures that have now already incorporated many of these refrigerant and ODS and global warming potential concerns into government procurement and large-scale replacement market-based pressures. So if I look at this from policy angle, and then how one can look at it from a private sector perspective, getting consumers to be a part of it. And again, plethora of global experience of how consumer engagement has driven the demand for the industry. Unfortunately, in India, we've sort of had a very early start with our eco-labeling program, EcoMark, but it's sort of stagnated. But I see that it's a huge opportunity for us to come back and do a market demand-driven, backed on our experience of energy efficiency standards and labeling and other things. BIS, the eco-labeling green air conditioning requirement is a very good start because it addresses the large segment of room air conditioners. And it looks at issues beyond efficiency at global warming potential, affordability, emissions, resource use, and safety. Now, sustainable public procurement is another way of looking at it and driving this change. Do you look at life cycle analysis and total cost of ownership? And recently, we worked with the Ministry of Finance and UNEP to look at how procurement, which is driven by life cycle climate performance, and which government takes the first edge, make a change in the market. So the green room air conditioner was launched on e-marketplace on the 5th of June. And now if you go to that portal, you have from industry green air conditioners, which are 5-star and beyond. In fact, they're 20% more efficient than 5-star with low GWP refrigerant, available at the same cost as a 5-star, and sometimes even cheaper depending on the feature. So, it can actually change the market over a period of time. So it's possible for us to look at market as driver for some of these changes. And the last point I want to make is that, linking it to corporate climate commitment. So there's countrywide commitments, but sorry about that. My dog is going crazy. To corporate climate commitments, and companies have done that, and they have realized that they have to look at refrigerants and their cooling technologies as an important aspect of that. Thank you.
Thank you, Mr. Tathagat. I think as I was, preparing for this panel discussion, and as I was also listening to all of the speakers, the fact remains that, and I think this is what Mr. Tathagat and also Mr. Nagahari alluded to, that there is an enabling environment. So at this point, I have more answers than I do have questions, because we have all the ingredients for the perfect recipe. But these technologies remain at the fringes. At this point, I would like to pose a question. Is the 10% or 10% natural refrigerants in the market, or is NIK remaining at the scale that Mr. Dontula mentioned? Is this the maximum capacity it can reach? Is there an opportunity to push further? And if there is an opportunity, what is currently missing? Maybe I'll ask Mr. Dontula to respond to this, and then if Mr. Nagahari and Tanmay Tathagat can add on to this. You're muted, Mr. Dr.
Thank you, Aprupa. It's a interesting question. We always see like Mr. Tathagat and Mr. Nagahari mentioned, there's a lot of things going on already, and India is a big country, 20% of the world's population. So we have a huge range of requirements. Our climate zones are varied. We are going to have a mix of solutions because we have a whole range of requirements, from homes of one kind, single room homes, small shops, all the way to, big tech parks. And I'm not even talking industry and cold chain and other things. So I feel, first we have to be realistic. NIK, natural refrigerants, I feel will grow have to grow and will grow. But at what level? I think there's a lot more headroom than talking about what level right now. Yeah. I feel there is a couple of things. We have to recognize there's a particular situation in India. Our levels of comfort are different than the rest of the world. And that is not only because it's India, but it's every country is different. There is a whole field of adaptive model. Okay. And our whole area of comfort is about temperature, and hence heat load, and hence efficient buildings. So if we can first start, and then all the buildings, because of the way vapor compression systems have evolved, all our buildings are also tuned towards making vapor compression system work. Okay. So if I put all this together, what we have to say is that, we have to start, even Mr. Nagahari said this, we have to be speaking to architects, students, everyone. And you can't fit in a NIK technology in an existing building always, because they work different ways, So fortunately, the building square feet area is going to explode, according to the various studies, ECBC studies, in the next 10 years. But replacing a current HVAC installation with NIK, one-to-one may not be always possible. So we have to think about generating new building space, so which incorporates some of these things. And I'm not talking about passive cooling, which is a whole different ball game, so that is one. So a lot of work that needs to be done in awareness creation. The second is, we don't appreciate today how much IAQ is important, humidity is important. In this context, I think there was some very good work done at CEPT and other places on the Indian, and other organizations contributed on the Indian model of adaptive comfort. We see this in changing of the set point. We talk about changing of the set point from 24 to 26. But when we talk about Indian model of adaptive comfort, this is not a fully air-conditioned building. We're talking about mixed mode buildings. And this is what is a lot of that in India, mixed mode buildings. So when you talk about mixed mode buildings, then you have to mainstream the ideas in the Indian model of adaptive comfort, I feel. So again, a lot of education with architects and others, and a good set of case studies. I feel there has, similar to disclosures on green buildings and energy efficiency, there must be a mandate on IAQ. Why again IAQ? Because conventional HVAC has been shown to be contributing to these health issues, and then we put band-aids on it, and we put filtration, and we do other things, and UV lights, So the moment you put in other factors, NIK technologies become more suited, because they have come from, they're actually proven over the years. For some areas, and we haven't talked about this while we talk about space cooling, there are particular cases where, like data centers, this is not addressed in ICAP, we can incentivize NIK, and I'm not aware of those policies, but specific areas, we can actually incentivize NIK there. And so I just, and I feel if the awareness increases, then there will be a more collaboration between, it can't be just conventional HVAC versus NIK or any, or, natural refrigerants. It's all collaborative. So there has to be a greater amount of interaction, among the various manufacturers, because you have to have a solution which is best for the consumer. And I am convinced that it will be a mixture of technologies. That itself will go a long way. Does that,
Yes, thank you. Thank you, Dr. Rukala. Mr. Nagari, would you like to go next?
Yeah, sure. So thanks, and I think Prasanna brought out some very important points on IAQ and collaborative efforts that are required here. And see, clearly, one aspect that I brought in also becomes important as we move forward on low GWP and natural refrigerants is how easily can we keep the operational people out of that place so that they feel safe. And if that happens, probably we will see more adoption of these technologies, where probably the digitalization and electrification of the other industries that is happening, if that can get fast forwarded into this industry, we will see a lot more adoption of some of these technologies here, which we are already seeing. I mean, we are able to remotely control a lot of things from many kilometers away. So we do see that kind of taking shape, and that in itself will help. But the point is, how can these NIK that we are talking become the mainstream? That's the larger goal that we are looking at, and it is not going to happen overnight. And in that space, I think we also need to kind of understand which are those applications which are low hanging, which we can immediately look at and kind of move in there. And clearly we are seeing that kind of applications already available in places like condensing units or bulk milk chillers, in the transport refrigeration, for example, in the food processing industry, in cold storages, in slaughterhouses, in the dairy industry, poultry industry. These are places where currently today probably there are in some places already ammonia is being used, but because of safety issues, there is a chance that they will move back to a freon. And how do you enable and create an environment where they can either continue to use natural refrigerants or move into a technology which is a cascade or a transcritical system, so that they don't go back and again come back into something. So we also need to look at how do we ensure what we are doing well, we continue to do well, while we create an ecosystem and look at some of the applications which are long term. District cooling, for example, is not going to happen unless there is a clear regulation in place on how are you going to circulate chilled water across roads. So these, we have to look at different pieces together and build all of that together into an entire system, and then we will see scaling up of this happening. And I think that's the long and short of the answer.
Thank you. Mr. Tathagat, would you like to?
Sure, I think a lot has been said already, so I'll just make it just 2 points. Your question is, with all this stuff happening already, and we're talking about enabling environment already being there, why is it still 10%, or why is it not scaling up to that extent? From the answers, it's clear that there are 2 or 3 large segments where a transition is possible and is maybe the first mover. So if I look at industrial users, applications in large commercial applications, refrigeration applications, in many of those cases, the decision maker is an informed person. So they actually are fairly aware, but their priorities are driven by cost and, of course, risk mitigation, the lowest risk possible to processes and to things. And that's where we find that still many of these technologies, which are the, say, some of them may be mature for certain applications, but then they may be cost prohibitive. So the whole ecosystem for catering to such large scale applications is yet to come. Now, this is recent in India's context. So I see that changing. I see that there are certain industries and certain applications where, as you can see, things are happening without any policy or any other incentive, because it is actually a cost effective and a better option already to either go evaporative or to look at other alternatives. But in the end, it has to be cost effective, and that is very important. When we look at natural refrigerants, then in many cases maybe the efficiency is lower, or maybe the cost is higher, maybe the maintenance cost is higher, maybe there are other issues. The other large area which we need to address is the residential air conditioning. While there is a lot of other things to be said about changing the way we live, changing the expectation of comfort, despite all the initiatives in that direction, the demand for room air conditioners is going to grow. In that segment, even if I look at, say, continuing the same demand and maybe reducing it by other methods, there is already proven technology. So Godrej has proven, for example, that it is possible to have a product which is efficient, performs well, and is cost effective. So what is it that is stopping them from taking? And those are very minor issues that have to be tackled at the other end, maybe on the industry side, at manufacturing side, of how a manufacturer can easily switch because they have a business case, but there are other policy impediments that we all know about. And then there are certain, I would say, marketing issues where there is negative marketing done, right? So that's a sort of a public awareness issue. But I think that, if I just look at this transition from 10% to, say, having a 30 or a 40 or a 50% in the short term, just looking at these certain informed industry and segments which can be influenced if they are assured of a good product at a reasonable cost, and then the small air conditioners which have proven need to be prioritized to start that rapid transition.
Thank you.
Aprupa,
Thank you.
If I may
Yeah.
add one point, and it was alluded a little bit to by Mr. Nagahari, and this is not about natural refrigerants. This is about the NIK. In my opinion, a lot needs to be done on quality. So these RAC, I mean, the residential air conditioners or any other AHUs are fit and forget today. Now, if, as Mr. Nagahari mentioned, if maintenance increases, nobody desires that, if it is to be operated. So conventional refrigeration and air conditioning is a very mature industry. NIK has not evolved to that level of engineering, at that level of reliability of that things.
And
so
in
there's
many
a lot
cases,
to learn.
it is phased out because it had
Yeah.
problem. Like absorption cooling was actually quite popular.
Yes. Yes.
And it actually went out. So you're right. I mean, it was issues of quality and performance.
So now there has to be a lot more done to encourage these things. I mean, solutions exist. Yahoo runs a data center running on direct evaporative cooling. Facebook does that. Australia is one of the harshest climates in terms of UV exposure and other things. And they have wonderful evaporative coolers which run forever, externally mounted. So it's a lot of engineering work, and the scale of the companies is small in NIK. I think there's a lot to learn in that area. So that's why collaboration also is needed, because some components can be inserted in a normal machine. That's how the attitude we have taken in our some of our projects.
Right. Thank you. Thank you for that input. And it actually brings me back to Mr. Rajneesh Khosla, when we talk about, let's say, having or continuing the use of ammonia refrigerant in cold chain, and or the use of hydrocarbons for residential air conditioners, we're always talking about safety standards. And BIS has done its part in like bringing out the required standards for these equipment. Now, what are the next steps here? Like, how do we ensure that these standards are followed, or what are the kind of collaborative setups BIS would require or does see as a need for implementation of these safety standards?
Thank you so much. First of all, I would just like to add to the previous point also that the government is also incentivizing the green technologies. I think Terry has done a very good work, and now they were given a task of sustainable public procurement in India. So I think the government in its GEM portal, whenever a government body asks for a green air conditioners, so all the conditions that are there in the draft standard of eco-labeling, these are now part of the GEM portal now. So they would now, the government is incentivizing purchase of green technologies, and I think it will go a far way in increasing the percentage like you were telling. The other way is we have made the standard. We have not made the standard. People like Mr. Nagahari here, we only facilitate the making of the standard. I think all the credit goes to experts like Mr. Nagahari and other experts here who have contributed significantly, and my salute to them for being such a patient and trying to build consensus among experts in the standardization area. And we have made the standard with the collaboration of industry in such a way that once the QCO quality control order that is expected to come on 1st January comes, this will part, and these standards are embedded in the main standard. So once the QCO comes, the following of these standards would also become mandatory. So be it refrigeration standard, part 89, part 2 IEC, part 289, or the IEC part 40, all of these are cross-referred in the main standard, be it 7872 of the freezers. All these standards will become mandatory, that once the QCO comes into play, you cannot escape. You have to follow these safety instructions if you have to make a freezer using a natural refrigerant. So these will become mandatory from 1st January 2022 if the quality control order does not get postponed due to the COVID difficulties that are being faced by the industry. So all these standards have been made in such a manner that the safety consideration will become mandatory when the standard are made mandatory by the government, which are expected by 1st January 2022.
Okay. I think one of my last questions, and because we don't seem to have any questions from the audience, would be, so I do realize that political motivation, and in fact, everything is going in the right direction. And I think right now, an important aspect is going to be, we make sure we're planning this transition right, and we make sure we have the policies in place. I think I want to go back a little bit and understand from Mr. Tathagat what the role of private actors could be in this transition, and especially from the perspective of, okay, let's create awareness or anything else that needs to be done, the role of civil society organizations, research organization, and industry in building capacity specific to these alternative technologies.
Right. So at a broader level, I think, this was a question that was asked earlier and is in the Q&A as well. Vinuta had asked about, connecting and linking public health concerns with the larger issue of efficiency, refrigeration, refrigerants, the choice of refrigerants for all of us as individuals and society, and what is the, right now it's the whole issue with the common good. So we don't really factor in the environmental impact of refrigerant use in any of our decision making. Because that causal link is not there. And it's a very important job of the civil society to, bring that dialogue from policy to really connect it to lives of people and decision makers. So that's, I guess, one really critical role. The other one is, the moment we link to it, issues of ozone depletion, global warming, ozone depletion issues, for example, were demystified. They were directly linked to people getting cancer, right? And that really changed the way people looked at all kinds of sprays and started changing the way they would even. So that is very important that, as civil society, we private sector, we look at demystifying and bringing that cause. The second part is private sector is the linking of, business model. I said there are two things. One is, we people like Madhusudan who really done this really interesting work, which is not just technology, but it is how do you actually make it a part of a business where you're not offering necessarily always technology, but you're offering a service, right? So changing that, then you can really look at alternatives in a significant way, because you have taken the decision of technologies and refrigerant away and consolidated it, which becomes easier to handle, right? So and instead of 1 million people trying to look at which AC to buy, if they're served by systems which are consolidated, either district cooling or any other cooling as a service model, it's easy. That's again, the business model is a part that private sector can take and propagate. And the last bit I come back to is the linking of this issue of refrigerants and choice of cooling methods and technologies and alternatives as a direct has a direct impact on the climate commitments that corporates are making. So from Indian companies, from TCS to others, they all have very ambitious targets, right? And they also have, therefore, the resources they have allocated for this. And they just need to create that link. And the last bit was, I think it was raised by Mr. Dantula, is that the quality of service and offering really needs to improve significantly as a product, whether it's a service or a product or a technology. And if there's an Indian standard, it must be adhered to. And those kinds of things build confidence for people to make this change.
All right. Thank you so much for your response, Mr. Tathagat. And I think at this time, it is clear that a lot can be done to assist the growth of these technologies. And I think through this panel discussion, we attempted to deconstruct some of these aspects. I thank our panelists for sharing their views and their time on this issue.